SAT test 9, question number 10 on the non-calculator section. You're given an expression and actually you're given an equation, and the statement says that it is true for all values of x, which means that equation has infinitely many solutions, or is the so-called identity. When you are provided the fact that an equation is true for all values of x or has infinitely many solutions, these two things means the same. We have the so-called identity, which means the left side is absolutely identical to the right side of the equation. And you're asked to find the value of a times b, where a and b are constants. The logical steps in these questions are always the same. First, you're going to make both sides be in standard form. That means if they're like terms, you're going to combine them. And if they're parentheses, you're going to double distribute them or triple distribute them depending on the problem. After that is done, you will make sure that the coefficients in front of the corresponding exponents of x are identical on both sides. So as I said, my first step is to get rid of the parentheses. So I'm going to start distributing ax and 3 to put that left side in standard form. So when I start distributing, I'll have 5ax to the third minus abx plus 4ax. And then I will distribute the 3, which makes it 15x squared minus 3bx plus 12. And I know that this has to equal 20x to the third minus 9x squared minus 2x plus 12. I don't have like terms on the right side. I do have like terms on the left side. So what I'm going to do in the next step is I'm going to put that left side in order, meaning in order of the highest to the lowest exponent. So I'm going to start with the cube, of course, and then I'm going to go for, sorry, here I have a square that I forgot. I'm going to go to the square terms. So I have negative abx squared plus 15x squared. Then I'm going to list the x terms, which are 4ax minus 3bx plus 12. And that has to equal 20x to the third minus 9x squared minus 2x plus 12. Because of the constants a and b, I really can't combine like terms. That's why I'm going to the third step. Since this equation is true for all values of x, this equation represents the so-called identity in algebra. That means the left side is identical to the right side. What does that mean? Is that the coefficients in front of x to the third on left have to be identical to the coefficient of x to the third on the right, and so forth. Everything, coefficients in front of x squared to the left have to equal the coefficient in front of x squared to the right, and the constants also have to be equal. I need to find AB, right? So I am going to focus on finding where is AB. Well, I noticed that AB is a coefficient in front of x squared. So knowing that before mentioned property of identities, that everything is identical, I'm going to focus on the x squared terms. Where are the x squared terms on the left? The negative abx squared and positive 15x squared. So which are the coefficients of x squared on the left? I have negative ab and positive 15. That has to be identical to the coefficient of x squared on the other side of the equation. It turns out to be only one, negative 9. And this is what exactly is going to solve my problem for me. I'm going to subtract 15, and I'll get negative ab equals, 15. And I'll get negative ab equals negative 24. Which makes AB to equal exactly 24. And this is the solution to my equation.